Okay, so I asked very clearly here, solve the same problem but in a non-replacement problem. So you didn't do it?
No, I didn't, and I watched the video.
Your book's in your desk and not in the... That's right, it's on the video.
Check the video, I watched it.
Did you?
I'm being honest, I didn't watch it.
So you didn't do it? Okay, well,
I did it though.
you've only got an exam coming up. It doesn't matter if you don't do your work. So,
Julianne, I'm
just
gonna
to remind you, what we have is a situation, right, where, what were we looking at? A bag, we're pulling 2 marbles out, and I wanted to know what was the probability of getting a pink marble and a green marble. So I asked you to start with, well, what was the case if that marble gets put back in? So a replacement problem. So we did it, we've got pink and green, so we're multiplying. This is a, what diagram did we say?
Sample space.
So sample space diagram. So we did it and we got an answer of 24 out of 144. So I introduced you to a tree diagram instead, right? So then we'll get to a stage which we're going to do, where tree diagrams will be what you have to do. Because sample space diagrams only work when you've got 2 things happening. So as soon as we go beyond that, we can't use them anymore. So we went through, did the same problem. So we wanted to know pink and green, so you can see how we've got 2 roots. And I showed you that there is another branch here for not pink and green, but I just stopped because I'm not interested in it. Okay? Right? But just to start us off, what would be the probability of getting others?
5 out of 12.
So you should be able to tell me this without even seeing the bag of marbles. 5 out of 12. How do you know that?
Because you have to add up 4 and 3 add up to 7.
So all of these have to add up to 12 out of 12, or 1. Okay? So every set of branches has to add up to 1. So in this case, when I work out the ends, all of these would eventually have to add up to 1 if I considered all of them. But we'll talk more about that in a bit. But we stopped here because I'm not interested. I only want pink and green. I'm only taking 2 marbles. So as soon as I've got something that's not pink or green, I have to discount it. So I only wanted 2 roots, the pink followed by green and the green followed by pink. So I took the probabilities and I did 4 trials times, because that times is I got a pink and a green, and then this one was green and a pink. But of course I can consider either of those, so one or the other. So all means adding. So I multiplied to go along the tree, so multiply in that direction. When I want to consider all of those, I add them together when I've got more than one option. Now I ask you then to do the same problem but in a non-replacement way. Alright? So let's consider that. So let's just go pink and green. I'm not going to write anything else. And then obviously we go pink and green again. I don't need the pink because obviously I only need pink followed by green. But just so I have a diagram. So the 2 roots I need are pink followed by green. So I want to know what that is. And I want green followed by pink. So I want to know what that is. Right. So obviously in an exam, quite often what you'll be asked to do is fill in the odd space of a tree diagram. Maybe not the whole thing, right? You'll be only asked to do certain branches. But what would be the probability of getting a pink one?
The first one?
The first marble would be pink.
4.
So it's 4 out of 12. What would be if the first marble was green? What was the probability?
3 out of 12.
Yeah. Okay. Bearing in mind what problem we're doing. What is the probability of getting a green for the second marble?
3 out of 11.
3 out of 11.
Ooh, so
Okay. What's the probability of getting a pink second?
4 out of 11.
4 out of 11. Okay. So what would be the probability of getting a pink, then a green?
12 out of 100.
It would be 4 over 12 multiplied by 3 out of 11. So I've got 12 out of 1. Okay. The other option is, what is the probability of green, then a pink? So that would be 3 out of 12 times 4 out of 11. So actually you get the same answer.
So what do you want to true? And then you add them.
So we add those together.
You have 24 out of 132.
Add those 24. Can you see how in this problem, if things changed, the problem was a bit more complicated. If I've got to add those together, I want the same denominators, don't I? So I don't really want to be simplifying fractions. So for instance, if they were different numerators but the same denominator, I don't want to simplify one and not the other, because then I wouldn't be able to add them together. I'd have to undo the simplification. So that's why I say in a probability question, you don't bother to simplify the fractions. In fact, I don't think they even ask you to simplify fractions in probability. If they want to check your understanding of simplifying fractions, they'll do it in a different way, in a different question. Right? So is it more likely or less likely to get a pink and a green in a with replacement or without replacement?
Without replacement.
So without replacement. Because it was 24 out of 144, it's now 24 out of 132. So it's more likely to happen.
Isn't that supposed to happen? Like
Okay.
in an ideal world.
An ideal world.
In an ideal world. So what would that, how would I interpret that result then? Give me some possible interpretations of 24 out of 132 using the vocabulary we've talked about before.
Can you repeat the question? Agreed.
So there was a word, rather than the likely and stuff, that just interpret the 24 out of 132. What I gave you some vocabulary. So I would expect
Out of 132 times, 24 of them would be pink, then green.
not just pink then green, but and green. So if I were to take 2 marbles out, so without replacement is like taking 2 of them out. If I were to do that 132 times, I would expect to get a pink and a green 24 times. Okay? Does that make sense? Right. I've got another problem for you then. So, normal problem for you. Okay? So like an exam problem. An archer. Do you know what I mean by an archer?
No.
Bow and arrow. Okay?
Oh, yeah. So did I. I used to shoot.
Fires 3 arrows at a target. Okay? The probability of hitting the target on the first, no, sorry, not just on, the probability of hitting the target is 1 in 8. Okay?
1 in 8 what? 1 in 8.
Interpret it. What does it mean?
Every 8 tries, they got 1.
Yeah.
Oh.
If I was to fire 8 times, I'd likely hit it once. That's his probability. How would we have got that probability?
Make him do it. He would have.
Yeah, that is the only way to get a probability with someone firing an arrow is to make them do it and work out your experimental
So
probability.
wait, P is hitting it the first time? Or
So,
just
no,
hitting it?
probability of hitting the target, okay, is 1 in 8, okay? Simple question to start with, right? I would like to know what's the probability of him hitting 2 times out of 3. What is the probability of hitting it twice? I would then like you to try and answer what is the probability of hitting at least once. I want you to have a go, see whether you can do it. Now, it's 3 arrows. So arrow 1, arrow 2, arrow 3. That means you've got 3 events happening, which means we can't do a sample space diagram.
Yeah.
So what are you going to have to use?
Tree.
Tree diagram.
Wait, what if you already worked it out?
Okay, fine.
Do we have to?
Oh no, write down your solution. What do you? Eventually, you'll get to a stage where you don't need to do a tree diagram. You've already got that right.
Do we have the question?
If you are already done, I will give you part B to this problem. So if you've already solved those 2, part B is if he hits the target, the next shot improves to a probability of a hit being 1 in 3. What is the probability of hitting twice? Okay, let's talk it through if we're struggling. So,
I just my mind.
let's just make this very clear. This probability of the archer hitting the target, okay, is something that's been set for you.
Right.
Right, I said, how do you interpret that? Now what that means is, it's not very likely that he's going to hit the target.
Yeah.
If I were to interpret in terms of expected frequencies, I would say, well, based on that probability, I would expect him to hit the target once in every 8 goes. Right? Therefore, if he hits the target the first time, well, theoretically, for the next 7 goes, he's going to hit. He's not going to hit it. But there is a problem with that, isn't there? Because every time he fires the arrow, the probability doesn't change. So, if he fires and does hit, if we were to say every 8, it's got to be 1 every 8. Well, if he hits the first one, the probability of him hitting the second one would be 0. Because if he hits the first, and then you apply that to the next one, so that's why you can't say, well, he has to have 8 arrows there. Every arrow has a 1 in 8 chance. So if I hit with my first arrow, we could say I've been quite lucky, right? Because I've got a 1 in 8 chance of hitting it. What's my chance of not hitting it? 7 in 8. So it's a much higher chance of me not hitting this target. So if I do hit it first time, brilliant, done very well. That doesn't mean my next shot has a 0 chance of hitting. It's still got a 1 in 8 chance of hitting. Alright?
What if the day between like
Now you're talking about changing the probability, which I've done in part B. Let's talk about this probability of hitting 2 times out of 3. So what we are going to do is we're going to look at this tree diagram. So the probability of him hitting the target is 1/8. Right? So he takes his first shot. He will either hit or miss. Okay? What is the probability of him hitting?
1 out of 8.
1 out of 8. What's the probability of him missing? 7 out of 8. Right. His second arrow then, he could have hit the first one, but regardless of that, he could still hit or miss with the second one.
Right.
What's the probability of him hitting the second throw? Still 1 out of 8. This is still
7
7 out of 8. He could have missed. So, hit, miss is still the options, and it's still 1 out of 8, 7 out of 8.
And that goes
Right.
to like 8.
It can go on forever, but we only have 3 arrows. So he could have hit, miss, hit, miss,
Oh god.
hit, miss, hit, miss. Okay? Right. So this is where tree diagrams can get really big. Right?
Right.
Oh, so
But it's
you
still 1 8, 7 8, 1 8,
Oh, it's
7, 8.
7 8,
tree now.
1 8, 7 8.
It's the
Okay.
branches.
Yeah, it's all the branches.
It does look like
Now, what
So,
we have to
because-
consider, to remember, the biggest thing I would say about probability is knowing how many possible outcomes there are, which I guess you girls fell for, didn't you? To start with, you just went hit twice. Well, that's the problem. But what does hit twice? How often does it happen? So I could hit, and then I could hit, but then I would have to
Miss.
not hit, exactly. So I would have to miss the second one, right? I could hit, then miss, then I would have to hit, right?
Or you can miss it.
Or I could miss, then hit, then hit.
Or you can miss.
I've got to hit twice.
Miss.
You can't miss. Why can't you miss hit?
Because that's hitting
Hitting
once, not twice.
True.
Okay? So, what I now have then, I'm going this way along the tree. So I multiply. So hit, hit, miss is 1 8 times 1 8 times 7 8. Now what do you know, just to help speed things up a bit, what will the next one be? 1 8, 7 8, 1 8, yeah?
They're all the same.
Not the same? Are you okay then if I just do times 3?
Yeah.
Alright? Because it's 1 option, 2 options, 3 options. And because they're all independent, there's no change. So I just do 1 8. So that would be 1 times 1 is 1 times, well that's 21 over 8 times 8 times 8 is, sorry, 520, 512. 512. So, 21 out of 512. Not likely to happen though.
No.
No. Hitting them twice.
True.
Right. So, does that make sense?
Yeah.
So you can see the tree diagram is useful because what it does is it helps you figure out how many different combinations of 2 hits there are. Now you could have said, just listed it and gone hit, hit, miss, hit, miss, hit, miss, hit, hit. You could have done that as well if you wanted to do it and then just done the multiplication. Tree diagram helped, I think, visualise. Now, the next question was, what's the probability of hitting at least once? So, probability of hitting at, and this is a very common question, at least once. So,
Hit, miss, miss.
so yeah, let me,
It's just one. No, it could be.
so it could be hit,
Miss.
hit, hit. That's at least one.
Oh.
Could be hit,
It's just all of them except for
miss,
miss.
hit, it could be hit, miss, it could be hit, miss, miss, it could be miss, hit, hit, miss, hit, miss, 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 hit.
Exactly. Not miss.
So it's actually all of them apart from
Miss, miss, miss.
the last one. So only this last one is not considered. So does that mean we are going to work out all of these and add them together?
No.
Not necessarily. We're gonna subtract times by 6.
What I'm actually going to do, and this is a comment, there's two ways to do it. Yes, I can work out all the branches and add them together.
Just have to
However,
1 minus miss, or like 1
we can
something.
do 1 minus the probability of 0 hits. Because the only option not considered with at least 1 is miss, hitting no times at all. So actually all I need to do is work out the probability of missing all. So that's 7 over 8 times 7 over 8 times 7 over 8. So that, well, I know it's 512, so 7 times 7 times 7 is...
49 times 7.
Yeah, but that's like 3 over 1.
49 7 times 7 is 300.
When you multiply fractions, you do tops and bottoms.
Yeah, it's 300.
What's 7 cubed is?
It's 300.
Thanks, Taylor.
Check it if you like. 8 times 8 times 8.
No, it's just 8.
I think I see what you
It's like
mean.
12.
When you multiply by a whole
Yeah.
number, you only multiply with the numerator.
It's 343.
343.
So 1 minus.
Now don't forget that is that, so we've got to do 1 minus 343 over
Are you gonna do
512.
that?
So is,
So then
It
it's
is.
It's go.
so I would do 512
Over 4.
minus 343 over 512, which is
0.33.
Oh, you didn't do that one.
Just wait.
Was she laughing?
just do 512 minus 343.
I got a decimal.
That's because you're doing this as a fraction, yeah?
Yeah.
So we don't need it.
SD.
Yeah, if we do that, S to D, 169. So we end up with 169 out of 512. Okay. Alright, so full question there.
Can we do another question?
Well, you haven't done part B.
What was part B?
Oh boy.
Okay, so we're going to use the same thing. I would suggest you're going to need a new stem and leaf, new tree diagram. New tree
We
diagram.
have forgot histogram.
So-
What's a histogram?
Oh.
We'll go through it, but
Oh, I remember.
right.
What about these down?
Now, listen to me. Stop distracting yourself. This time, so you're going to need to do a new tree diagram. You have to consider it very carefully. So I've got the same thing. What's the probability of hitting twice? However, this time, if he hits the target, the next shot improves to probability of hitting of 1 out of 3. The reason is, if you hit it, what you do is you do exactly the same thing again to hit it again. So it's more likely that you'll hit the next one. Alright? Now, of course, that only impacts the probability if he did hit previously.
Oh, no.
So, for instance, if I hit the first one, the probability of hitting the first one is
1 out of 8.
1 out of 8. The probability of then hitting again would be 1 out of 3, because he hit the first one, so probability of hitting, okay? The probability of hitting the third one is still 1 out of 3, because he hit before, so it doesn't keep improving. However, if I hit my first one, the probability is 1 out of 8. If I then miss the second one, the probability of hitting the third one is still 1 out of 8. Because you only improve your probability if you hit the one previously. So because you hit the first one, doesn't improve your probability of the third one if you miss in between. So you need to draw your tree diagram and consider how that impacts all the probabilities all the way through. So this is considered conditional probability.
If you have a hit, you have a.
So really, we're only considering again the yellows, so we've got the same three, we've just got different probabilities.
So we still need the miss.
Right girls, because I'm conscious, actually it's almost lunchtime already. Right, let's just just fill in these probabilities before we go. So, probability of him hitting, 1 out of 8.
Right.
Miss, 7 out of 8. Now I've only got the 3 options I care about. If I hit the second time, this changes to
1/3.
1 out of 3. Okay? But missing becomes 2 out of 3. Okay? If I hit, then hit, missing, well, the probability of hitting a third time would be 1 out of 3. So this miss must still be 2 out of 3. This time, hit, miss, my hit goes back to 1 out of 8. This one I miss, so I hit becomes 1 out of 8. But hitting a second time is 1 out of 3.
So for 1, 2, and 3, make it different. Like,
So I've got 1 over 8 times 1 over 3 times 2 over 3. Or 1 out of 8 times 2 over 3 times 1 out of 8. And this one is 7 over 8 times 1 over 8 times 1 out of 3. Now you can see the denominator
72.
is the same every time, but the numerators will be different. So we can't just times by 3
all
this
the
time.
denominators are close.
Because it's, oh no, sorry, it's not. 8 times 3 times 3 is different, isn't it? So
Yeah.
first one's slightly different. So I'll let you
Oh yeah.
finish that off and work out the probability.
For now.
Well, it's lunchtime now, so when you come back.